Good morning, guys. Now we are in second unit. Actually, second unit this deals with the mineralogy and petrology concepts. Now, yesterday we discussed rock forming minerals and ore forming minerals. Now, here today we will discuss classification, structures, textures, and forms of igneous rocks. Here, definition of igneous. Igneous set of rock or a mineral that solidified from molten or partly molten material from magma. Etymology Latin igneous and fire. Here magma. Magma is naturally occurring mobile rock material, molten rock, capable of intrusion and extrusion. Igneous rocks are derived from magma through solidification and related process. Viscosity. Viscosity is the property of a substance to offer internal resistance to flow, its internal friction. When water viscosity is low, rubbing alcohol is some better. Ethyl glycol is some better compared to rubbing alcohol, and vegetable oil is more viscosity. Flow viscosity, initial position and after flow starts. Viscosity increases from left to right. Viscosity in magma. Video shows a rod being poked in hot, viscous magma on Fluker, Hawaii. Here, factors influencing the viscosity of magma: temperature, chemical composition, and gas content. These factors influencing the viscosity, viscosity of magma. Temperature. The higher the temperature, the lower the viscosity. Basaltic magmas at 1200 degrees centigrade are higher, are much more fluid, less viscous than granitic magmas at 800 degrees centigrade. Here, low viscosity flow animation, typical of basaltic magma. Chemical composition. The higher the silica content of magma, the higher the viscosity. Gas content. As gas content increases, the viscosity decreases. Gases inhibit, silica chain formation and lower overall viscosity. Effects of increasing viscosity. Volcanic violence related to viscosity, magma type. Magma type related to geologic and often plate tectonic setting. Partial melting. Different minerals melt at different temperatures. As temperature increases, This leads to partial melting. Here, igneous structures. Igneous are intrusive igneous rocks and extrusive igneous rocks. Here, intrusive igneous rocks, magma freezes below the surface. Extrusive igneous rock, magma erupts onto or above the surface. Here, intrusive igneous rocks and extrusive igneous rocks figure is there. Intrusive structures, plutons. Plutons are larger bodies of magma that solidified well below the surface. Magma may be injected under pressure into cracks in the rock. Intrusive structures continued. Here, the horizontal line here black is called a sill. Approximately it's 10 kilometers, but we can identify this type of intrusive structures in field only. Igneous sill, parallel to existing layers. Here, igneous sill, Salt River Canyon, Arizona. The dark band is basalt intruded into horizontal layers of igneous rock. Here, this is the sill intrusion. Intrusive structures like a dike, layered rock 1 to 10 meters. Igneous dike intrusion cuts across the rock layer. This is the igneous dike. Thin pink alphite dikes cut the block, basaltic dikes, and the gray granite. Its location Penderhalber, South British Columbia. Here the igneous dike, where here the white exhibits vertical is called the dike. And igneous structures diagram. Here crystallization of igneous plutons and erosion. Here batholith is the chamber of the magma and dikes, volcanic neck, sills, laccolith. These are all the igneous structures diagram. Aerial view of intersecting dikes. Intersecting dikes, territory age at Spanish peaks, Los Animas, and here Spanish peak dikes. West Spanish peak, 13,623 feet, and dikes territory Los Animas. Intrusive structures, Laccolith. It's approximate 1 kilometer. Just the magma chamber formed in the below the surface of the earth. Igneous Laccolith. This is the example of the igneous Laccolith. Here, Shiprock, New Mexico. The neck of an ancient volcano which has eroded structure in the background is a dike. Here, igneous vein. Extensional veins in a thick carbonate turbidite from the Ligurite complex in the northern Apennines, Italy. Photo David Bryce, Carleton College. This is the igneous vein. Here, the white is exhibits the igneous vein. Extrusive structures, lava flows and obsidian. Here, lava flows from the air. Lava flows from the ground. Lava flows from Nirangango volcano eruption January 18, 2002. City in Goma, Congo. And Newberry caldera origin. Obsidian flow from a vent along the south wall of caldera. A road gives scale. Obsidian domes. Halos in obsidian domes. Long Valley caldera, California. Obsidian is formed from very viscous magma which is unable to flow long distances. Next, obsidian, upper left, thin piece of obsidian showing flow barely. Lower left, thicker piece of obsidian showing conchoidal fracture. Classification of igneous rocks. Mineral content, chemical analysis, texture, geologic association. Mineral content. Igneous rocks may be classified on the basis of what minerals they contain. Essential minerals, auxiliary minerals. Chemical content. Rocks may be analyzed to see what elements they contain. Results are reported as weight percent oxides. Texture and fabric. Texture is the general physical appearance or characteristic of rock. Fabric refers to the orientation or lack of it in space of the elements of which a rock is composed. Here, abaenitic texture, a very fine-grained texture with crystals, invisible to the naked eye. Phenolitic texture, grains are visible and identifiable using the naked eye. Perforatic texture, large crystal in a fine grain are aphanetic ground mass, andesite porphyry, and closer. Here, pegmatitic block hills, South Dakota, core structure resulting from rapid crystal growth due to presence of water in melt at the time of crystallization. Arrows point to the location of spodumene crystals removed during mining. Spodumene is a source of lithium. Here, relation of texture to cooling history. Aphanitic rapid cooling leads to very fine crystals or to glass, typical of extrusive rocks. Phenetic slower cooling leads to medium or coarse grained rocks, typical of intrusive igneous rocks. Pegmatitic very slow cooling in a water-rich magma leads to the coarse crystals. Porphyritite, porphyrite slow cooling while the magma ascends through the earth, followed by rapid cooling after the magma erupts on the surface. Crystals are often medium to coarse. Ground mass texture will be fine grained or glassy depending on the rate of cooling. Geologic association. Rocks associated by age, position, and by characteristically being found together. Constant or regular variation of features within the rock body. Here, bounce reaction series. Temperature is bounce reaction series. Here, high temperature 1200 degrees centigrade, cooling magma. Lower temperature 750 degrees centigrade. Here, alvin and calcium rich ultramafic rock. Pyroxene, amphibolite, basaltic mafic rock. Here, discontinuous series of crystallization, alvin to pyroxene to amphibolite, amphibolite to biotite mica. This is the discontinuous series of crystallization. Calcium rich, plagioclase feldspar. Here, continuous series of crystallization and sodium rich. Biotite mica. Here, potassium feldspar, muscovite mica, and quartz. This is the bounce reaction series. Here, igneous rock types ultramafic, basic mafic, andesite intermediate, and granite felsic. Bound Tuttle experiments. Fractional crystallization, crystal setting, and partial melting. Fractional crystallization, evaluation of magma. Over time, fractional crystallization changes of composition of magma from A to B to C. Magma body, host rock, and lava and magma composition A. Crystallization and setting, lava and magma composition B. Here, crystallization and settling, lava and magma with composition C. Here, the difference is in first figure, magma body only. Here, after some time, crystallization and settling, and after more time, crystallization and setting is taken. Intrusive versus extrusive rocks. Intrusive, medium to coarse grain, 100% crystalline, may contain inclusions of rock which fell into the magma as xenoliths and extrusive rocks, appentic to fine grain size, often glassy, often contain gas and bubbles. Here, granite, rhyolite. Granite has clearly visible crystals. Rhyolite has a few visible crystals and patches of glass. Both rocks are felsic. First one is the granite rock. Second one is the rhyolite rock. And diorite andesite. Diorite has visible felsic and mafic crystals. Andesite has mainly felsic crystals visible. Both rocks are intermediate. Gabbro and basalt. Gabbro is composed of dark visible minerals. Basalt is dark with no visible crystals. This piece has many gas bubbles. Both rocks are mafic. Obsidian. Obsidian is volcanic glass formed by a quick chilling of the magma after eruption. This specimen is called snowflake obsidian. The white crystals are cristobalite, a high temperature form of silica which crystallized before eruption. Peridotite, ultramafic intrusive rock, characteristics of the Earth's mantle. Genolith, genolith of metamorphic amphibolite in dunite, and ultramafic igneous rock. Andesite line, andesitic volcanoes, continental crust, and the zone of melting, descending plate, and the trench ocean crust, the depth up to 100 to 150 kilometers. Geographic boundary between the basalt or gabbro of the Pacific Ocean basin and the andesites at the subductive margins of the surrounding continents. Okay, guys. Today just I completed the igneous. Today our class we learned only few things. That is like classification, structures, textures, and forms of igneous rocks. In our next class, I will clearly describe sedimentary rock formations. Thank you.